Today we're going to be working on 7.5. In 7.5 we're doing all of the same things that we were doing in 7.1 through 7.4. So we're writing, solving, graphing, but instead of doing those things with equations, we're doing those things with inequalities. Inequalities have no equal signs. Instead we're going to be using less than, greater than, less than or equal to, greater than or equal to. When we're looking at key phrases that will lead us to write down these symbols, we talk about for the less than sign, we make a capital L with our fingers, and if we squish that down, we get the less than sign, so L, less than. So if we see the words less than or fewer than, we're going to be writing down a less than sign. Over here, if we see the words is greater than or is more than, we'll be writing down a greater than sign. Over here we see ones that say less than or equal to. If we have one that says less than or equal to, it will say is less than or equal to, and then they give us these right here. These ones are a little bit trickier. The four down here are a little bit trickier because it'll say is at most. So usually when we think of most or more than, we think of the greater than sign, but because we see the word at and no, we're actually going to do the opposite, and we'll do a couple examples of this in a minute. Over here, under the greater than or equal to sign, obviously is greater than or equal to will make us write that sign down, and then we see the same thing, at least, no, less than. We're actually not going to use the less than symbol for these because they have the words at and no in front of them. So we're looking for those words, at and no, and if we see them, that should be a little red flag to us that we're actually going to use the opposite of what we think we should use. And again, we'll talk about that more in example 1. Alright, in example 1, we're writing inequalities. Our direction word is to write. Just like when we were writing when we were writing equations, we're going to translate this. If translating from a word sentence to a number sentence is confusing, I believe that was back in 7.1. We had a list of translations on one side of the paper. Those would all still work here. The only difference is that when we see the word is, we are not going to write down an equal sign because inequalities do not use equal signs. They use less than, greater than, less than or equal to, or greater than or equal to. So it starts out the same. On number C, we write down C, but where it says is, we can't write an equal sign because this is an inequality. Is less than, so if I look up at the chart at the top of the paper, is less than negative 4. B, a number K plus 5. Where it says is, again, I can't write an equal sign because these are inequalities, is greater than or equal to, 8. That's how the majority of the problems will be. They're pretty straightforward. The new part is realizing that is less than means we should write down the less than symbol. Is greater than or equal to means we should write down the greater than or equal to symbol. But then we get to problems like C. C is where it becomes just a little bit trickier. 4 times a number Q, so 4 times a number Q, is at most, and we see that red flag word at, 16. So I can put the 16 in while I think about what sign I need to use. First of all, I can just look up at the table. Is at most means we're going to use less than or equal to. We talked about most and more. That would kind of make us think we should use the greater than sign, but at is our flag word that this is one of the ones that's different. And I'll give an example over here. In this problem, 4 times Q, if I put a number line going up and down, the most it can be, at most, is 16. So if I put 17 up here and 15 down here, I want to think about, well, which one can I have? If it's at most 16, can I have 16? Well, yes, it could be 16. If at most I can have 16, then can I have 17? No. If the most I can have is 16, could I have 15? Yes. So I actually want the numbers that are less than 16 or equal to 16, which is why we're writing the less than or equal to sign. Another example we talked about in class was my minivan. So I have a minivan. It has 8 seat belts in it. So I can carry at most 8 people in the car with me. Well, in total. So yes, I can carry 8 if I have at most 8 seat belts. Could I take 9 people? No. Could I take 7 people if the most I can take is 8? Yes. So again, we're wanting numbers that are less than or equal to 8. Down here towards the bottom of the page, number 4 is another example of one of these weird ones. A number z divided by 2, and then we see is at least. At is our red flag word that this is going to be different than what it sounds like. And then it says -6. So if the least number I could have, and this is a little tricky because it's a negative, so we'll just kind of think of it as, well, we can use -6. If the least number that I have is -6, then can I have numbers that are smaller than that, or should I have numbers that are bigger than that? If this is the least number that I can have, then I want to have numbers that are greater than or equal to -6. Alright, on the back of the next page, we start talking about solutions to the inequalities. So solutions are answers. Again, inequalities do not have equal signs. They're the ones with the other signs in there. The solution of inequality is a value or a number that makes the inequality true. We have a lot of experience with this in equations from the beginning of Chapter 7, so we're going to do it exactly the same way. One new thing is that an inequality can have more than one solution. It can have more than one answer. In equations, if we saw something like x plus 1 equals 4, the only thing that would make that true was if x equaled 3. So we can only have one solution to that equation. But as we're going to see here, we can have something called a solution set. A solution set is all the answers. So not only are we going to have more than one, we could have an infinite number of answers, and all of those answers put together are going to be called the solution set. So we'll look here at this example. If x is 3, and they're giving me this inequality, x plus 3 is less than or equal to 7, I'll rewrite it. I'll put 3 in for x because that's what it's telling me. 3 plus 3 is less than or equal to 7. I'll simplify. 3 plus 3 is 6. Is it true that 6 is less than 7 or equal to 7? Yes. So x can equal 3. So that's one solution. Let's look at 4. X plus 3 is less than or equal to 7. Plug the 4 in where x is. 4 plus 3 is less than or equal to 7. Simplify. 4 plus 3 is 7 is less than or equal to 7. So is that true? Is 7 either less than 7 or equal to 7? Yes. So here's our example. We have 2 answers that make this true. So my solution set so far has all of the answers that work. So right now in my solution set, I have 3 and 4. So now we'll check the next number, 5. So rewrite. 5 plus 3, is it less than or equal to 7? 8 less than or equal to 7. Is 8 less than 7? No. Is 8 equal to 7? No. So since my answer is no, the number I originally started with, 5, is not part of this solution set. So again, this is driving home the point that in equations, we could only have one answer that made it true, but in inequalities, we can have 2 answers or more that make it true. Alright, so we'll look at example 2. The directions tell me to tell whether the given value is a solution of the, and again, now we're on inequalities. We're used to seeing equation right there, but no equal signs in inequalities. So we'll look at A. This is set up very similar to the other sections of Chapter 7. X plus 1 is greater than 7, and they're giving us x equals 8. So I'm going to take 8 and plug it back in. 8 plus 1 is greater than 7. 9 is greater than 7. Is that true? Is 9 greater than 7? Yes. So yes, 8 is a solution. B. They're telling us 7y is less than 27, and they want us to see if that is true when y equals 4. 7 times 4, is that less than 27? 7 times 4 is 28. Is 28 less than 27? No. 4 is not a solution. C is a fraction. Z divided by 3 is greater than or equal to 5. They want us to see if that's true when Z equals 15. So 15 over 3, is that greater than or equal to 5? 15 over 3 just means 15 divided by 3. Is 5 greater than or equal to 5? Yes. 5 is equal to 5. So yes, 15 is a solution. In the last notes section, we talked about the fact that there can be more than one solution to an inequality. Oftentimes, there's going to be hundreds or thousands of possible solutions. If I look at this one in example 3, g is greater than 2, any number bigger than 2 is an answer to this inequality. So 3, 4, 5, all the way up to 1,000,001, 1,000,002, all the way up to 10,000,001, 10,000,002. All of those numbers are greater than 2, are bigger than 2. So we can't possibly write out all of the solutions that will make this true. So because we can't write it down, we're going to graph the inequality. The graph of an inequality shows all the solutions of the inequality on a number line. An open circle, which means a circle that's not colored in, is used when a number is not a solution. A closed circle, a colored in circle, is used when a number is a solution. An arrow to the left or right shows that the graph continues in that direction. So, when I want to graph g is greater than 2, we draw a number line and put whatever number they're giving us right in the middle. So I'll put the number 2 right in the middle of the number line. Then I'm going to pick the numbers on either side. Usually we'll just do 1 away or 2 away. So what number is 1 smaller than 2? That'd be 1. 1 bigger than 2 would be 3. So 1, 2, and 3. Now, to start off with my graph, I'm always going to put a circle on the number that's in the problem, the 2. I need to decide if 2 is a solution to this. So if I put a 2 in for g, will this be true? If it is true, if it is a solution, then I'm going to color the circle in. If it's not true, if that's not a solution, I'll leave the circle empty. I'll leave it as an open circle. So if I put 2 into here, I would have 2 is greater than 2. That is not correct. That is not a solution. So because it is not a solution, this is going to stay an open circle. Now I need to decide which way do the rest of my solutions go. So if I put 1 in for this, would 1 be greater than 2? No. What if I put 3 in? Is 3 greater than 2? Yes. So all of my numbers that work are the numbers that are this way on the number line. So 3 would make that true because 3 is greater than 2. 4 would make that true because 4 is greater than 2. 5 would make this true because 5 is greater than 2. If I picked a number that would be here, so what number would be right in between 2 and 3? That'd be 2.5. 2.5 would make this true because 2.5 is greater than 2. So instead of having to list tons and tons of solutions, We just draw this arrow to say any number that's bigger than 2 would be greater than 2, would make this work. And again, we have an open circle here because 2 does not make this true. So we got a false here, and a true here. We're going to look at some examples that go with example 3. So again, continuing with graphing. Let's look at one that has a less than or something with an equal to sign on it. So P is greater than or equal to -3. So I'll draw a number line. I'll put the number they give me, -3, right in the middle. We know that -4 is smaller than -3, and -2 is bigger than -3. And we're always going to put a circle on the number it gives me in the problem. So I need to figure out what numbers are greater than -3. So we can test again like we did up in example 3, or we can think of some shortcuts. So the shortcuts are, if there is an equal to sign in here, so a greater than or equal to, or like over here in number 9, a less than or equal to, we're always going to be coloring the circle in because that's saying -3 can be equal to -3. So if we have an equal sign, it'll be a closed circle. If we do not have an equal sign, like in example 3, it will be an open circle. We need numbers that are greater than -3. I could test -4 and -2, but the shortcut is just this arrow points us in the direction. So if I look at my greater than sign, it kind of looks like an arrow going that way, which means my arrow should go this way. And then we can think about this and double check it. Is -2 greater than -3? Yes. But negative numbers are often really hard for students to understand because that's kind of a newer concept that they're working with. So it's definitely a good way to help on problems with negative numbers. But those same kind of quick shortcuts will help with every graph. So for example, in number 10, put 0 in the middle. We'd have a -1 and a 1. There's not an equal sign, so it will be open. The arrow's pointing this way, so the arrow should go, or I'm sorry, the sign looks like an arrow pointing that way, so we'll point this way, and then just check it. Is 1 greater than 0? Yes. Thank you for watching this 7.5 lesson. If you are a student who has been watching for extra credit, the secret code word is football. If you have any questions, please feel free to email me.